to our 12th workshop. Thanks for Ben from Starkware to join us today and to talk a bit more about how to start with StarkNet. So yeah, I'll give you the floor and yeah, feel free to ask questions as well, but I'm sure they'll welcome you with warm welcome.
Cool, sounds good. Yep, so my name is Ben. I'm a dev advocate at Starkware. Go by Dr. Spachemin on various platforms. So you might have seen a neon rabbit pop up somewhere. That's me. So yeah, today we're going to go over a tutorial that we just recently put out called StarkNet Accounts. And it is about StarkNet accounts, but it kind of masquerades around a lot of different dev tooling. So we'll be using a lot of different community dev tooling like StarkNet DevNet, StarkNet Pi, and PyTest. So if those, I'm sure some of you guys are using those for the hackathon. Pretty big libraries, pretty major libraries, and if not, and you guys would like to learn how to use them, we're going to do it, and you're going to see some code employing them. So I'll do a screen share, but feel free to just stop me and ask any questions that you have. If there's a chat, I believe, right? I'll try to keep an eye on that. But yeah, feel free to just reach out and ask me questions as we go. So are you guys able to see my screen?
Yep.
Okay, great. Okay, so the tutorial is StarkNet accounts, and this is in StarkNet edu GitHub organization. So we have a couple different tutorials in here that go over various primitives of the platform, Cairo 101. I don't know if you guys follow Henry, but we just recently migrated all of the tutorials officially into this organization. So we lost like 300 stars. It's mostly just vanity, but it still sucks. Anyway, but yeah, so this one's StarkNet accounts. As some of you guys probably know, accounts on StarkNet are implement an account abstraction model. And that just means that accounts are smart contracts. So it gives a lot of flexibility in how devs and the community implement them. There are a few caveats to that, and we'll go into it. But for the most part, the really cool thing about accounts on StarkNet is that they are smart contracts. So implement any arbitrary logic you want. So I'll try to do this from pretty much scratch, and then you guys can follow along with me if you want. So I'll just blow away my local repo here. How's the font size in the terminal? Can you guys see that?
It would be great if it could be a bit larger. If that works.
What's that?
Yeah, maybe another time bigger.
Right.
That's great. Thank you.
Perfect. Cool. So we will clone the repo. We have a couple different dependencies. So these dependencies are for Cairo Lang. So you guys probably already have them. If you want some more information on how to set up a Cairo environment, it's in our main docs, which is linked here. And actually, let me just send this out in the chat real quick. Yeah, so feel free to follow along with me. And if anything's not working, just stop me and grab me, and we can figure it out. So there's a couple tutorial specific dependencies. This is for console printing in nice colors. So you can see some like, oh, things are going very right, or things are going very wrong. Request is a HTTP request library. We will init our virtual environment for Cairo. And again, these are also in the environment setup in our main docs. These are some dependencies. So OpenZeppelin, you guys, if you're not aware of OpenZeppelin, they're a standardization. They standardize a lot of different smart contracts and smart contract standards. if we go into those repos, you'll see account contracts, ERC20 contracts, ERC7021 contracts. They've made it very modular, so you can either import some of their library calls or you can just use it as reference code. But as far as developing on StarkNet, I think OpenZep and Cairo contracts are a huge add. So we'll CB into the library, the tutorial, StarkNet accounts. We got the Cairo contracts. Okay, so StarkNet DevNet. While you're developing, I don't know exactly what everyone's background is, but typically in software development, it's good to walk through environments as you're starting to build, because you don't want to push your code to prod right away, depending on if something's broken or if you have bugs that you need to work out. So every dev is going to have a different workflow, but the one that I usually use is PyTest. So PyTest is just a framework that is written around Python. That there's a library in the main Cairo code base that implements a testing framework. So we'll show you guys some of that today. 30 minutes almost feels. We'll get through it. So StarkNet testing. You can see some examples in here, like contract test.py. You get an empty StarkNet with an empty state. You can deploy contracts and start unit testing. Super helpful. So unit testing isn't the end all be all. We do want to do some sort of integration testing. So if you think about your environments, like I was talking about, PyTest is usually a good one for kind of the lowest level. Make sure that your contracts don't have any low-level bugs. Make sure they compile. StarkNet DevNet. So StarkNet DevNet is written by Shard Labs. So you can think about that as the next environment up. I use it for integration testing, and we'll look at what that looks like. So StarkNet DevNet, and then StarkNet Pi. So StarkNet Pi is an SDK written by Software Mansion, so that we can wrap a bunch of important platform tooling in Python calls. If you don't write Python, if you write some other language and you're looking for an SDK, I think the best place to look is Awesome StarkNet. And you'll see a whole bunch of different platform resources here. So there's a header here called libraries. And if let's say you're a JavaScript dev, StarkNet.js is a great library. Kaigo, that's a library I maintain with a couple of members of Matchbox, actually. Cool. So we've got our StarkNet dependencies in PyTest. And if you want to do asynchronous testing, we will grab PyTest async.io as well. Let me boost on there. Okay. So a lot of StarkNet EDU repos have a similar framework, and that is that there's going to be an evaluator contract written in Cairo that's checking that you've implemented some logic in your smart contract that meets the goals, the objectives of the tutorial as we've laid them out. This one is slightly different in that it comes with these Python files as well. So when we're interacting with them, it's kind of a shim to help you understand what's going on. To kind of jump back into the environments, we're going to start on DevNet, and then we're going to go to TestNet. TestNet deployments and TestNet transactions do take some time to propagate through the system, which is another reason why it's much nicer to kind of step through your development cadence on PyTest, DevNet, and then something like TestNet. Cool. So hello.py and hello.cairo kind of just orient us with how the tutorial's laid out. So we will check them out. CD contracts. I use VS Code and Vim, but we'll use VS Code here. How about the font size in the code editor? Is that okay for you guys?
Yes, it's good.
Okay. Awesome. So we got the README, a couple things in miscellaneous. Don't worry about that. Hints we will touch on later. So the main meat and potatoes here is the contracts folder. These are some constants that for the most part if you're curious about it, you can take a look at them. You don't need to touch much right now. Accounts.json. So for the evaluator that has been deployed to testnet and the other libraries that it depends on, these are the contract hashes. So if we wanted to go check out on Voyager, which is a block explorer maintained by Nethermind team, we can go check it out. But we will start our cadence at our lower levels, which is PyTest and DevNet. So hello. So we'll check out what this looks like. Hello.Cairo. So this is the simplest account contract you can have on StarkNet. And again, this is a StarkNet accounts tutorial that's masquerading over like, hey, let's use some cool tools and build on StarkNet tutorial. So as far as the accounts tutorial, since accounts are just smart contracts, there's one caveat to that, which is that accounts on StarkNet have a canonical entry point of an execute function. So it needs to have an external function that's named, explicitly this name, execute, with the 2 underscores in front and the 2 underscores in back. And that's it. As of now, that's it for an account contract. So this is the simplest account contract you can have. And as we're parsing through what account abstraction means, it is typically that the account contract is executing arbitrary logic for a known entity. The way that usually manifests itself is a signing scheme, and so some things will be out of scope. So if you're wondering, how is ECDSA, how does that actually work on a really low level? We're not going to get into that, but there are multiple different signing schemes that can be used. EOAs, for example, on Ethereum use SCCP 256K1 and SHA 256. And account abstraction is something that the Ethereum community wants for the same reasons that we wanted it, which is it allows flexibility in the implementations of wallet design, of recovery schemes for your keys, multi-sig wallets, really just a whole host of different cool use cases for accounts. But to draw it all the way back to hello.cairo, what you're looking at right here, this is kind of the simplest account contract you can have. And you'll probably notice if you're looking at it that there's no concept of a signing key, a public key or a private key. So this would just execute arbitrary logic that's sent into it, and it would call another contract and execute that logic. Any questions on this execute entry point or kind of simplest account you can have? Cool. So let's take a look at the Python script. Again, this uses StarkNet Pi. So each exercise that we walk through, and we're probably not going to have a ton of time to get through them all, but hello, signature 1, signature 2, signature 3 all have a Cairo file and a Python file, and all the Python files look very much like this. So what are we going to be trying to accomplish? Deploy an account contract with an execute entry point, fetch the random storage variable from the validator contract. You don't necessarily need to read the entire validator contract, but if you are curious, you can either look at it the deployed one on testnet, or you can look at the Cairo code here. But there is a get random view function here. So the goal is to get that value and then pass it back to the evaluator contract. So get client. Python and a lot of the SDKs function with a client. Once things become much more decentralized and once there are multiple sequencers, you'll see that these clients are RPC related and that they're also they might be HTTP related. As of now, let me parse through that a little bit more. So there's an JSON RPC spec similar to how the P2P is enabled in Ethereum. And right now we have a full node named Pathfinder that we can query and currently has implemented most of that spec. But right now there's one sequencer that's run by Starkware. So if we're trying to interact with the platform, interact with the chain, we're going to be hitting that sequencer via HTTP calls. So when we say get client here today, we're really talking about a client that connects to the API for the sequencer. But in the future, you'll see that be not only JSON RPC, but probably WebSocket as well. So deploy account. Deploy account. So there's one other caveat for account contracts on Cairo, on StarkNet, and that is that they must be compiled with an account flag. Utils, we will go into deploy account contract. So this is the other caveat. When compiling, the compiler needs to know that this is in fact an account contract. Okay, so we will deploy the account and then we fund the account. So as of one of the more recent platform upgrades, state changes to a smart contract state and storage require a fee payment. Right now, that's priced in Way, and the account contract is the fee payer. So even though we're calling an entry point on another contract, the initial entry point that's going to be hit is this execute entry point, and the account that has the execute entry point is going to be the fee payer for that transaction. If you're curious about kind of how fees are broken down, we have some really good documentation on it. But as a high level, you can think that you just pay for the L1 footprint of your transaction. So if you're curious about fees, there's a breakdown here. This is also a really good home for documentation for devs that are kind of wanting to dig down a little bit more. Okay, so we fund the account that we just deployed here. And then we're gonna get the random call. So again, this is all StarkNet Pi specific. This is how we call a view function on a contract, on a deployed contract. And then we're going to have an invocation request, and the invocation request is going to start with the execute entry point. For accounts, that's always going to be the case. It's always going to start with an execute entry point. And then what are we calling? We're calling the validate hello function of the evaluator. And we have to pay fees, so we specify a max fee here. Okay, cool. So DevNet starts with an empty state. So even though the evaluator is deployed on testnet, we'll need to deploy it on DevNet. Okay, also, so we have not started DevNet yet. So what we installed DevNet, and now we will start DevNet. Cool. DevNet is super, super helpful. So it starts out with some pre-deployed smart contracts for accounts, and they all have this amount of Way for fee paying. If you started out with a deterministic seed of 0, we know what the account addresses will be. So if you look in the hints.json file, this is hard coded just because we know the sequence that started the pre-deployed accounts. So this is the first account in that deployment scheme so that we have a fee pair. Okay, so we will deploy the evaluator contract. And while that's deploying, we'll just briefly look over what it is. In that evaluator deployment, we actually deploy 3 contracts. We deploy a player registry, an ERC20, and the evaluator contract. So when you walk through these exercises and you implement them correctly, and we go and we call, depending on the exercise, we call, let's say, validate hello, which is the one we're about to look at, we get paid. We get paid in worthless ERC20s. So you should get paid once you get it right. I'll show you what my wallet looks like on testnet. If you do all of them right, you'll collect 4,200 ACT tokens, and you get to brag to all your friends. While this is deploying, does anyone have any questions? We're running out of time. Does anyone have any questions?
Yeah, like don't feel tired by the time. We can overlap easily. I don't mind, and if you don't too, feel free to continue. It's like super interesting for me.
Cool. Yeah.
I guess.
I think if you guys are cool, we can just verify that hello.py works, and then you guys can kind of go off on the rest of the exercises with some level of confidence. Does that work?
Hey Ben, are you reading the chat? Someone is asking a question in chat.
Thank you for the session. Okay, so the question is, I entered the hackathon in hopes of deploying to StarkNet using Warp by Nethermind. Are there any resources aside the GitHub that you can point me to? So yeah, Nethermind just released the second version of Warp, which is supposed to be pretty comprehensive. I have not used it yet, and I would personally point you to the GitHub of it. Let me ask internally, and do we have some way to follow up with the people that attended the session?
You can come to our Discord and just post in the Hackathon channel if that works for you.
Okay. I'll follow up with you, but yeah, right now I would just say the GitHub is probably the best place to look. Cool. So if you look at these logs up on the top, this is the DevNet. We see a bunch of 200 requests. So those are all coming from the Python scripts and deployments. So 200s across the board. We look like we're doing pretty okay. Registry is deployed here. ERC20 is deployed there, and evaluator is deployed there. So since contract debugging is can be hard, we have a cache here. So if you think that the smart contract that you've written is bug free, but you think your interactions with the evaluator are maybe not correct, then this is where the cache comes in. You don't have to redeploy every single time. You can just know exactly where the contract address is of the contract you're currently testing. So we also save the addresses of the evaluator to reward token and registry here as well. Cool. So hello, we'll do the same thing with hello.py. So just to reiterate, we are fetching a client, deploying an account, and the account is just this simple execute. Fund the account so that it has some funds to pay for invocation fees. And then we're calling get random on the evaluator, which we know where the evaluator is because it's in our accounts.json file, and just submitting that invocation. So let's check it out. Cool. Yeah. So like this, the details of the deployment will also be printed to the terminal. And if everything was coded right, you should see, alarming red text for things that have gone poorly and alarming green text for things that have gone well. So we just deployed that hello contract. We also compiled it, saved it in our cache. So hello is in our cache, and we got a payday. So we successfully passed the evaluator checks for hello. To verify that, there's a couple different ways you can do it. I'll show you the way I like doing the best, but in the repo, I also put a curl here, so you can just curl in your terminal. I find Postman to be a better tool. So we have a StarkNet EDU has a Postman collection. It's just called StarkNet EDU with a bunch of the requests that you'll probably make. In fact, a lot of the SDKs wrap. Really, what they do is wrap some of these calls. Okay, so just to verify that we did indeed get paid, and we should have gotten paid. How much money? 100 points. We'll call the ERC20 contract and check the balance. So what contract are we calling? We're calling this from our cache. The entry point will be, there's a little conversion tool that we have, and it's linked in the repo as well. But if we want to get the selector for balance of, it's right here. So we'll check the balance of my account. And the account that will be credited was the reward account that we used to actually fund the Hello World account. If you're interested in how that works, this fund account is in utils, but for now you can just know it was the one we transferred ETH to pay gas fees from. So for DevNet, that is this account here. We'll change to DevNet. Sweet. So this hex representation should be nice. Cool. So that's the basic workflow of it. You get a taste of StarkNet DevNet. You get a taste of some of the SDK work and Postman. So yeah, have fun with it. If you do get stuck, there's a hints folder here, and this is, I actually will show you that real quick. So in hints, if I wanted to run one of these unit tests, it's PyTest, and then the name of the unit test. So PyTest will run this unit test here, which again has that testing framework that we looked at the very beginning of the session today. And then this should give you some hints on what the evaluator is expecting. If you need even more hints, there is a branch of the repository. So the branch of the repository is called hints all, and this has PyTest scripts and Cairo code that all just works. So you could just call, those scripts and they'll execute, and you can see what they're expecting. But yeah, by and large, that's about it. So if there's no other questions, or are there any other questions? Do you guys have anything for me?
Hey, yeah, I could have one question. Currently, for deploying some smart contract using Cairo, I'm mostly using the Hard Hat plugin. So is there any reason to prefer the plugin that you show instead of the hard hat plugin of StarkNet?
Nope. I think whatever tooling that you've kind of picked up and gotten comfortable with, that's all good. So far the community has put forward a lot of great tooling. It's kind of like if you're a Python dev, you probably would gravitate towards StarkNet Pi. If you're a JavaScript dev, you probably gravitate towards Hardhat. Or if you're even a Solidity dev, you probably gravitate towards Hardhat. So just whatever you're comfortable with, really.
Okay. Thanks a lot for your answer.
Yep, no worries. Anybody else? Okay. Well, I appreciate your time, guys. And Emmanuel, I'll get back to you on if there's any subsequent work documentation besides what's in the repo. And yeah, thanks for your time.
Yeah, thanks a lot, Ben. It was super clear and interesting. Obviously, if anyone has question, reach out on Discord, and we'll make the intro with Ben if it's necessary, or if you are on Discord, Ben, feel free to react on the Discord on the general channel. So yeah, thanks a lot, and have a good evening or late evening for some of us. And thank you. See you at the next workshop.
Good luck with the hackathon, everybody.
Yeah, good luck with building. Thanks, Ben.
Thank you. Great class.
Thanks.
Bye.
Thank you, guys. Have a great day. Bye.
Have a nice day.